program of the CN laboratory. So this is about a semi-wireless network. We'll be using ESS, which stands for Extended Service Set, where you will have multiple access points. So that was an introduction for ESS. So as you can see in the topology, I've not named it. So consider this as N0, this is N1, and this is N2. Since it is some semi-wireless, there are no duplex links connected between the nodes. So between N0 and N1, this is for like only one access point. So this is a basic service set, and between N1 and N2 again basic service set. Combining both of these BSS, that is basic service sets, we'll get a ESS, that is extended service set. So that was about the topology. And coming to the program, we create the simulator object, which is mandatory. Then you create the trace file. This is all explained in the previous programs. You can look up to it more briefly in the lab 1 program. And here in this program, the NAM file creation is a little different, because since it is a semi-wireless network and the nodes are not attached, they can be like moving on in the network and there is no restriction. So in order to have like a boundary to the nodes in the network, we use set topo in order to set the topography. That is, new topography is the syntax, where $topo, we reference it and load flat grid 1000 into 1000. That is nothing but the flat grid size for this particular boundary. Then you open the like NAM file, that is set nf. This is the same that you do in the previous programs. But here what happens is you specify it as wireless network. Sorry, it's about wireless network. So $n is NAM trace all wireless, and $nf will be referencing simulator object to the NAM file. Then 1000 because the flash grid size is 1000 and 1000. Then again the mandatory procedure, that is procedure finish. This is similar. You can look up to into the other programs that I've done to get the explanation for this. And since it is a wireless network, we need this configuration. So this is, you just have to write it as it is, the case sensitive, the spaces, the capitalization, everything should be same, otherwise your program won't work. So it is $ns node config, and there should be a space here, otherwise your program won't work. And you have ad hoc routing, R should be capital, and you have DSDV, and you have a space, then you have a slash. So DSDV is destination sequence distance vector. Then here, coming to the next line, just have to press 3 tabs in order to get alignment, so that it should be below ad hoc routing. So that is the format. So coming to the first one, that is LL type, where this should be as it is, because it's a configuration, and it should be written as it is. So LL type, capital LL, then you have MAC type, then you have IFQ, then you have IFQ length, then you have PHY type, then you have channel type, then you have prop type, that is propagation, and you have ANT type, that is antenna. Then you have topo instance, that is for the topo views for topography. Then you have agent trace, then you have router trace. So all of this have to be written as it is, otherwise your program won't work. And the spaces is also important, so 3 tab spaces would do. And you'll be creating God object. This God object is because since it is a wireless network and the nodes will be without a boundary, in order to configure them we use the God objects. So since we have 3 nodes, N0, N1 and N2, you'll be creating 3 God objects. So create God 3. So God full form is operations director, general operations director. So you'll be setting up 3 nodes, set N0, N1 and N2 with the syntax $ns node. Then you'll be labeling them. So you'll be referencing $n0, and you'll be using TCP0 there. For $n1 you label it as sync1, since the traffic from N0 will come into N1, and from N1 the traffic will be going to N2, that is why N2 is labeled as sync 2. Then we'll be having to set the, since they are moving all the nodes, it is not fixed, and that's why we set XYZ coordinates for each of the nodes. That is $N0 set space, you have X underscore space, then you have the coordinate 50, and for Y goes, and for Z again it's 0. Since we don't want 3D, we are only looking at the 2D, so we'll be setting Z as 0. For N1 the same thing, N2 the same thing. Then at like $NS at 0.1 you'll be setting the destination for each of these nodes, that is whatever you have set here you'll be setting it again, since they can start simulations at 0.1. And since we have mentioned for N0 we need here we'll be using TCP as the protocol, and that means you'll be using FTP as the package here in order to generate the traffic. So set TCP 0, you will be having the syntax new agent TCP in caps. Please remember it is case sensitive and you have to write it in case sensitive manner, and you'll be attaching the node N0 to TCP 0. You'll be creating set FTP 0 with the syntax new application FTP, and you'll be attaching FTP 0 to TCP 0. Then for sync 1, here you'll be setting up a sync object for N1. So set sync 1 new agent TCP sync. Then you'll be attaching the N1 to sync 1, and this sync 1 has to be connected to TCP 0. So $NS connect TCP 0 to sync 1. Then again TCP 1 is set up and it is connected to node N1, and FTP 1 the same syntax, and it will be attached to the TCP 1. And you have to set up sync 2 for N2, and that is the same syntax as I've told earlier to N2, and sync 2 should be changed from the previous one which we have looked, and you have to be connecting the sync 2 to TCP 1. So that is NS connect TCP 1 to sync 2 at $NS at 5 FTP 0 start and FTP 1 start. That is the traffic from N0 to N1 will start, and from N1 to N2 will start. And again for N1 you will be setting the destinations by changing the XY coordinates, and at $NS at 250 you call the finish procedure, and $NS run in order to run the simulation. So the AWK file is used. Here we are calculating the throughput. So here in the begin section you will have count1 variable initialized to 0, count2 variable initialized to 0, packet1 variable initialized to 0, packet2 variable initialized to 0, and you have time1 is equal to 0, time2 is equal to 0. So here as I have mentioned, $1 R means it is received. So if $1 equals to receive, if the packet is received and the sequence number here is _1, that is in $3, that is in third field, and $4 here it is in application layer, so it is AGT. So if that is the case, you do count1 plus and packet1 equals to packet1 plus $8. So that is packet field in the trace file, and time1 equals to $2, which is the time field. The same thing, another if condition for the packet 2, and the same thing goes except that for count 2 and packet 2 and time 2. And since in the end section this packet 1 is for N0 to N1s, and for N1 to N2 we have packet 2. So in the end we have the print for throughput, that is N0 to N1 percentage F Mbps, and this is the formula, that is count 1 into packet 1 into 8, time 1 into, you have 1 followed by 6 zeros, that is milliseconds, and this is the formula. And same thing goes for packet 2, that is for the throughput from N1 to N2. So that was about the first program. Thank you guys.